Hello guys, welcome back to Performance Engineering for Beginners. This is Suresh Kumar. Today the topic we are going to discuss is high CPU spin, how to debug that. Okay, so you may be facing high CPU in your environment or you want to learn how to debug this. So the cascading effect of a high CPU spin again is latency, throughput, the slowness in the UI. Every performance issue boil down to this three category. Okay, so on this topic, I also going to discuss how to use top command which comes inbuilt with Linux platform, as well as htop command which we can install on your platform. So I'm going to discuss both, and after that, first we're going to identify which process is consuming a lot of CPU. Once we identify that, we're going to isolate that particular process, neglecting all other process running on the top command. And then once we identify that particular process, we are going to one level up and see which threat is causing that particular issue. Is that a single thread or the multiple threads? Like each thread is consuming 10 percentage, 5 percentage of CPU cycles, which accumulate to 100 percentage, or single thread is taking lot of CPU cycle. That we're going to see. And again, one more thing we are going to say, that is thread process ID, which will be shown on the top command, which we are going to take it and we are going to match that PID to the thread stack, thread dump, which is called native ID in that thread dump. So PID is actually a decimal number it's shown, but however NID is a hexadecimal number. So we have to convert that PID into the hexadecimal number, then only we can able to get that particular thread details. I'm also going to tell how to convert in the command prompt from decimal to hexadecimal, and then in the thread dump using that PID we are going to navigate to that particular thread details. Okay, so I took this image some time back. From this you can evidently say, hey, there is something bad is going on the CPU usage. This will be very evident if you see that green color is a CPU time taken by that user and kernel, and the blue color is the garbage collection alone. So this kind of issue is very easy to identify in an environment, because it's going to bring down your throughput or increase your latency. Accessing the UI may be become slow, server becomes slow. So there are a lot of cascading effects due to this, but it's easy to identify because it's going to get everybody's attentions. But if you could see this image, you may ask me, what's wrong with this image? It looks very clean and neat. What if I told you this is the image of a and thread, single thread, consuming the CPU cycles more than 25 percentage without doing any business logic? Basically, it's not like handling any throughput or nothing. It's not doing any business oriented uh, computer. However, it's taking 25 percentage of an CPU in a single core. So this kind of issue is very hard to catch, and we need more deep level attention to it. So this time, like, we are not going to write any program because I want this session to be very short. um, However, I walk through the code. So some people has like how to do like this kind of activity for learning purposes. I also tell you some way to do that. So you can access the free version of AWS server from Amazon. Okay, so they have given 1 year free servers which you can use it for your learning purposes. So right now I'm using Red Hat Enterprise Linux 8 server, which is 64-bit. Uh, the problem with the first two was you may not be able to get the thread view on the Amazon Linux AMI. I tried that, it didn't work out. So I moved to Red Hat Linux Enterprise. So this is the configurations. So I have 1 GB of memory and one CPU core. So which is 82 dot micro. So this is the server I am using it. So you may can like register on the AWS, create your own servers. Make sure that you choose, if you are in India, make sure that you choose Mumbai. If you're wherever the local server would be great, so that you will get more response, high response time. By default it would be like US East, I guess. So I switched to our local server, so that I can get little more response time. So let's get on to it. So I'm going to launch my server. Okay, I'm going to full mu. Here I'm going to just do the top command right now, where I could see one of the Java processes taking almost 97% of the CPU. So this is what we're going to debug today. And see, when I set a top command, this is going to give me all the process which are running, which are sleeping, which are idle. So all the process. What if you want to sort it out to only the running process, which you can select it by hitting I option while running it. So this process filter everything out and will show you the running one. Okay, so from this you can see the main running process thing. So once you've done that, if what if you want only this particular process to be displayed on the top command, which is also we can do it. To do that, I'm going to create one more window this side. Okay, I opened the one more window. So I'm going to top minus hyphen p, which is going to give the particular process id, which is in our case this one, 15474. So 15474. So once you click that, we are filtered only that particular process. We are no longer going to see other process, because this is the process which is taking a lot of CPU cycles. So now we identified the process which is taking the lot of CPU. The next level would be what how to get into that process and see threat level. Either all the thread is taking a lot of all the CPU, or any single thread is taking the CPU. To do that, here I'm going to press shift plus H. What this view going to give us is thread level access for this particular process. So I'm going to press shift H. I'm done. Okay, so if you could see that it's displaying all the threads used by this particular process here. So if you could see that here, not all the thread is taking CPU. Okay, mainly this consumer thread. Okay, and this consumer here, if you could see, there are only two user thread, which is one is this. Okay, the other one should be not shown here. What the other thread is, this is system thread. This is more of GC related thread. Okay, so this particular thread is taking a lot of CPU. Okay, so now we know that this is the PID of this thread. Okay, so 15485 is the PID of this thread. So we are going to remember this number. Okay, before doing that, the next level, this is the decimal number. Okay, so before we are taking the thread dump, we are going to change this decimal number to hexadecimal number. Okay, so how to do that? You can just simply type printf on your screen console. So double quote percentage 0x slash n, which is next line, close one more double quote, and you are going to type this thread id, which is taking the more cb, which is 15485. Is it right? Okay, so 3c7d, this is a hexadecimal value which would be in the thread term, would look like this 0x 3c. Okay, so when we are capturing the thread dump, we are directly going to search this PID, which would be in the name of NID in the thread dump. Okay, let's move on to capture the thread dump. So I'm closed. So I'm going to use inbuilt jcmd command. Okay, so this is the Java process ID. So to take thread dump, jcmd, give the process ID, thread.print. I'm going to redirect this file to output to 15. You're done. So before going that, I just wanted to show this number. See, it is there. So if we could see is, this is the thread ID, this is the PID which have seen some time back here in the name of native ID, which is in hexadecimal. Okay, so this is the thread. So we saw that the thread name was const thread, consumer thread. So this is the thread. Now we are going to see. Okay, so I'm still going to copy this. I'm going to okay, so I'm going to search that. Here we go, here it is. So now you have done almost all part, because you identified the process which was using more CPU, and then one level up you identify the thread which was using the more CPU. You have captured the thread dump. Inside the thread dump you identified that particular thread which was using more CPU. Now if you see that, this is the class from you need to read it from bottom to up. So if you see that, so thread got initiated. So this is thread class which initiated the run, so it's created the basically the thread. Okay, if you see it, this is the class which is causing the CPU spin. So if you have access to your code, okay, so you can navigate to that this code at the line number 50, line number 58. You can directly navigate to that class and that particular line, and you can see what is happening in the thread, what is happening, what functionality being written on that thread. Okay, so before going that, I I want to explain one program, how this program been running in the behind, why it is spinning the CPU cycle. Okay, so what I have done is I have created one producer and one consumer. What is happening here is, okay, I have one list where I'm adding the items. Okay, so these items will keep on adding it until the I also have set one condition is progress equal to true. Okay, when producer is adding on the list, consumer will be waiting because producer locked all the list objects, so others cannot access it, so consumer going to wait. Here I have added one infinite while condition which is going to keep on checking is the progress is true or false. Okay, if it is true, it's not going to do anything. If it is, when it becomes a false, it going to tell consumer, and then it going to consumer going to pick the all the items one by one from the list. Okay, so in case if it is progress equal to false, when condition meets, it going to do. Okay, then his progress become false, allow consumer to consume data. So here one condition. So in this case, what is happening here is, when producer is producing this while condition thread, okay, which keep on going to check, hey, are you true or false, are you true or false, are you true or false. It's not executing any business logic, it's not like accepting any incoming data and processing, it's nothing, it's not doing any business logic. You just keep on checking continuously. It's because it's put it in the infinite loop until some condition is met which become false. Until then it will going to check it. So because of this, it continuously using the CPU. Okay, so it needed the CPU continuously on the while condition to check this. That is why here CPU is spinning high. Okay, for our learning purpose I have created this program. So I also walk through the code for this, and I can run it on the Eclipse and show you how, yeah, this is happening in the code level. Okay, and last one thing I want to show, one more thing is the difference between sleep and wait. See, sleep, when you put thread dot sleep with given some time, it not going to release the lock on the object. It going to hold that object until it sleeps, till it wakes up, which means that that particular object not going to available for other threads or other resources to process it. Okay, it's going to hold. But the wait, when you put it wait, what's the difference is, it's going to release that object. Okay, so the object is available for other thread or other process to process it. It won't lock the process. So this is the main difference. So it really need to we need to understand this. When you are using like a lot of thread dot sleep in your code, it's going to affect the performance drastically. Okay, so okay, so like I said, like this is the class name and the line number 58. That's where we are going to see. Okay, here is our program. Let's navigate to line number 58. Okay, so like I said, I have put one condition. What condition is this? This is true condition. It's a infinite conditions. It's going to keep on checking whether producer done with the adding item to the list. Until then it will keep on checking. Okay, so this is what actually it's consuming here. Okay, I'll run it for list item 1. It means that only one item I'm adding here. Let's run it for few times. Let's see what's the result we are getting at. So whenever it's going to use the more CPU, I'm printing this statement. Okay, so for example, let's run this program. See, the producer produced one item. Still here everywhere this condition being checked whether it's done. It's not done. So finally it's done, and then consumer starts to consume the product. Okay, that is, I'm printing consumed whatever I have added it. So let's see, run it one or two times. If you could see now, CPU it not spinning, it's immediately picked it up. So this kind of conditions, when we add in the code, we need to be very aware. Moreover, here if you could see it, I'm using the array list. So it's not the right way of adding the array list. We are supposed to use a blocking queue, which would be better for the performance. Okay, so here in the solution part, I rewritten the code entirely different, where I have used synchronized method, which you know that at a given point of time it will allow only one thread to lock the resources. Okay, so here let's say I'm going to add for say 3 items. Okay, here I have removed that while conditions. Instead I have put it the wait. Like I said before, wait is not going to lock the resources. Okay, so once you consumed, I'm printing here consume. Let's run this program. See, now first I am adding 3 item. Producer is adding 3 items. Producer is adding 3 items to the list. Okay, so wait, this dot notify, so it is notified all. I will discuss about much about wait, notify all in another session. So now consumer is starting to pick it up all the item whatever from the list. It's consuming 3 items. Okay, so this way we can avoid high CPU spin. So let me run one or two times. So if we could see all the time, it's fine. Okay, so what if I put larger number here on the item list? Instead of 3, what I've put 300. See, it added all the 300 items producer, and then consumers. It's locked list object is added everything. Once it is released, our consumer starts to consume everything, all the 300. This is not the case here in CPU spin. For example, if I add 300 or 400 in my loop, for example, I add let's say 1000 and let me run it. If you could see in between, there are a lot of CPU spin is happening. Producers is still producing. I added 1000 items, it continuously adding. In between, the other while conditions keep on checking and consume the CPU. So once it's done with the 1000 producer is added to the list, this CPU, that condition become false. The while condition become false. Is provisions is progress? No. So it tells a consumer to consume. So in the consumer consumes everything we have added till the end. Okay. So this way you can take the thread dump. You can take the thread dump and if you have access to the code, you can directly go and see the logic behind it. If you don't have it, like, you can walk to any developers who have access to the code. You can sit with them and see what is going on. You can understand that. Okay, so from outside world, see, it is what usually we search on the thread lock is blocked, deadlock, those keywords. Those keywords are very obvious, which is tells people that there is a problem. So, but this thread, it is running. It from the logs, it not showing any sign of problem from the logs. But we have to commit from that the process, thread level, CPU conception, all those things, and finally we identified this. So this is how we need to debug high CPU issue, guys. So you can post any questions. I can as much as possible I can answer. You can subscribe my video, you can add comments, you can share it. So thank you, guys.